Okay, this is a quick introduction onto this video of using tables to calculate averages. I'm going to do a quick recap on actually what these things mean before we go into doing the averages themselves, and I'm probably going to do it as two videos. So what we have to realise is that averages are talking about the middle values of our data, and what often people forget is what the table is showing. We have here the number of occupants, which is the thing we're actually counting. We are counting occupants of cars, so this is my data value. So all my averages are saying, what does a normal car look like? How many occupants does it have? The frequency, therefore, is the number of cars being seen. So when we come to do the averages, we're actually trying to find numbers in this first column, where a lot of people mess around with the frequency too often. Now, I'm not going to do it in the order that CIMT asked for. We'll deal with mode, median, mean, range as needed when we come through. Now, the next problem is people don't try and interpret what does this table mean. You should be able to describe what this first line means. You should be able to describe each line separately. So the first line is actually there are 24 cars with one person. So we've got 24 cars, 3, 4, 5. So there's my first 24 cars, each with one person in it. This is what your normal data actually looks like. Second line actually is 9 cars, 2 people. So we need 9 cars of 2 people. Now the grouping I'm doing up here just makes it easier when I come to look at data and where things are. I've now got, next line, 7 cars with 3 people. So 3. We have 6 cars with 4 people. One, 2, 4, 5, 6. Five. Oh, I missed out one of the 3s. So I didn't do the right number of 3s up here. I have 6, but there should have been 7 3s. So I need another 4, and now I have 3 5s, and we have 1 6. So this line is 3 cars with 5 people, and 1 car with 6 people. Now this column number times frequency is actually interpreting this to say how many people are there. This is trying to find out how many people were in all the cars, which is actually needed for calculating the mean. The mean will be people in a car. So I'd need to work out the total number of people. To do that, I've got 24, 9 times 8 is 18 people, 7 times 3 is 21 people, 6 times 4 is 24 people, 3 times 5 is 15 people, and 1 lot of 6, 6 people and none. And that is 6, 11, 4, 8, 16, 17, 22, 8. Carry 2, 2, 4, 6, 8, 10, 108 people. So the mean is 108 people in a total of 5 by 5 by 2, so that's 50 cars. So the mean is 108 divided by 50, which is 2.16. cars. When we come to describe the median, we have to find where is the middle point. Now, in the data it's quite easy to see. The middle is going to be somewhere between the first and the last. A good way to find the middle position is take the smallest, add on the last, so position 1 is the smallest position, 50 is the last one, and divide by 2. That gives me 25.5, and that says I'm in between number 25 and number 26. Now from my data I can actually see that the median is 2. But where does that come up in my table? Well, car number 24 is the end of that group. Car number 25 begins this group, so that's car 1 to 24, number 25 to number 33. So 25 and 26 are both in here. Number of cars, people in the car is 2. So the median number of people in cars is 2 people in a car. Scroll down, most common. The most common refers to the greatest frequency or the most number of cars, how many people are in them. So what's the greatest number of cars and what did the car look like in terms of our data? People keep forgetting to come back to the data column. So we need to read off the data column, not the frequency. The frequency says this is the most number of cars. Range, what's my largest value? Or data item minus the smallest. So if we go back to our original data still, my largest data item was 6, my smallest data item was 1, so my largest is going to be 6 minus 1, and the range is 5. If I want to find that in my table, there were nobody with 7, so this cut line could have been ignored. I have one person with 6. I have 24 people who had 1, but the first person was number 1. So the first person, number 1, the 50th person is 6. So the largest minus smallest is 6 minus 1, which gives me my 5 again. That's how you can use that table to solve the problem. The biggest problem people have is picturing the data, and that's what my data looks like. Okay.